Hello! In this video, we're going to see how to install a8s using the Operator Lifecycle Manager, or OLM, as I'm going to call it. The OLM is an open source project initially started by Red Hat to automate the lifecycle of custom operators in Kubernetes clusters. Installing a8s using the OLM provides some advantages over installing a8s by manually applying its YAML manifests. And the biggest one is that as new versions of a8s gets released, they get automatically installed as updates in your cluster. So let's actually go ahead. Here on my laptop, I have a Kubernetes cluster. And in fact, you can see its node. If I do kubectl get node, we can see that it has 3 worker nodes and 1 control node, that it runs Kubernetes 1.24, and it's a local cluster running on my laptop provisioned with kind. However, any Kubernetes cluster with a reasonably recent version of Kubernetes, either running on the public cloud or on-premise, would work for our purposes. So the first step to install a8s with the OLM is actually installing the OLM itself in the cluster, as it requires some components to run in it. So that's what we're going to do now. And to that end, I'm going to use another open source project called Operator SDK, which is related to the OLM. I'm not going to discuss its details here, but you'll find a link to its documentation, as well as to the documentation of the OLM itself in the description of this video. So Operator SDK OLM install. And this will start installing the OLM in our cluster. It should take a few seconds. Okay, the command has completed. This should have created a new namespace called OLM. Yep, it's there. And should also have placed the pods that run the OLM components in it. So if we do kubectl get pod name space OLM, yep, we should see there are some pods, and we don't care about the details, however. So with this in place, the final step before we can actually install a8s itself is by configuring the backup cloud storage. So what does this mean? a8s has the ability to take backups of the data service instances that you provision with it, for example, of PostgreSQL instances, and to upload those backups to a cloud storage of your choice. But this means that you need to configure a8s to talk to that specific cloud storage that you picked. And the way to do that is by writing all the needed information into local configuration files that will be read and parsed by the command that installs a8s. So let's actually set some backup cloud storage configuration parameters here. I have in my editor one needed config file. And for example, I'm saying that the provider for the cloud storage is AWS, which practically means that our backups will be uploaded to an S3 bucket. And then I'm writing here that the region where that S3 bucket is uCentral1. And finally, I'm saying to a8s the name of that S3 bucket and its shared backup. So with this information, a8s knows to which S3 bucket the backups must be uploaded. This alone is not enough, however, because that bucket is private, and of course you don't want your backups to be publicly available. And so we also need to feed in configuration files the access credentials to your backup cloud storage. And for example, we can do it like this: echo secret credential backup config secret access key. Actually, let me rename the credential secret access key. So what this mimics here is me writing in a local file the secret access key that a8s should use to authenticate to the S3 bucket when uploading backups. And of course, this is not a real access key that I'm passing. And the reason is that an access key is very sensitive and I cannot show you a real one in a video. There are other backup cloud storage parameters and credentials that you can set, and we don't have the time to see them all. So if you're interested about them, check out the a8s documentation. So once this configuration step is performed, we can finally go ahead and install a8s in our cluster. So let's do it. kubectl apply customize a8s OLM. This command, when we run it, will not directly apply the YAML manifest for the a8s control plane component. It will apply some higher level, more opaque OLM resources that express our desire to have a8s installed in the cluster. And the OLM will sort of take them and fulfill our desire by actually installing a8s. So let's go ahead. And okay, the command completed. And like I was saying, this should have created some higher level resources for the OLM, such as what's called a subscription. So, well, first of all, it should have created a namespace called a8s system, where the a8s control plane components will be installed, and here it is. And like I was saying, in this namespace, it should have first of all created some subscriptions for a8s. For example, kubectl get subscription namespace a8s system and say a8s PostgreSQL. So as we can see here, there's a subscription for the part of a8s responsible for managing PostgreSQL instances. What is a subscription? Well, a subscription is essentially a desire to have a certain Kubernetes extension or operator, like it's called, running in your cluster that, as I was saying, the OLM will fulfill. Moreover, once a subscription is created, the OLM will not only initially install the needed component, but it will also monitor whether new versions of it become available. And when that is the case, it will automatically update to the new version the component running in cluster. Eventually, the OLM should have fulfilled our desire by actually installing a8s, which means that if we look at the pods running in the a8s system namespace, we should find the a8s control plane itself. So if we do a kubectl get pod namespace a8s system, we should see 3 pods exactly, and these are the pods that make up the a8s control plane. Moreover, the command will have installed some custom resource definitions, if you're familiar with Kubernetes, which define new API types that describe either data service instances that a8s manages or lifecycle operations on them, such as backups. So for example, if we do kubectl get crd PostgreSQL, we should see that there is such a CRD, and this is the CRD describing PostgreSQL instances. And there's also CRD, for example, describing backups on PostgreSQL or any other data service instance. And yep, we can see that the backup CRD is there. So with all this in place, we're ready to go ahead and actually use a8s to provision and manage data service instances. To see an example of this, check out the 4th video of this series.